Hi there, welcome to Math with Mullins. Today we're going to look at the Chapter 14 test review, so make sure that you have that review sheet out. Here we go. Just as a reminder, feel free to pause or rewind the video if you need to copy down a concept or review a concept. When you are going through your questions, you need to make sure that you circle the ones that you missed so that you know those are the ones you're supposed to go back to and try. And then once again, the practice test is always available to you online if you go to our class website, mathwithmullins.weebly.com. Part 1 is going to consist of the first page from Chapter 14 test review, questions 1 through 16. Here we go. Number 1 says find the square roots. The answer to this one should be plus or minus 7. Notice that this plus or minus symbol is in the front, so we have to keep it as our answer. Number 2, we've got the negative square root of 16 over 81. Remember, if you've got a fraction, just break these up. Do we know the square root of 16? Do we know the square root of 81? Square root of 16 is 4. Square root of 81 is 9. Keep the negative. So my answer is negative 4/9. Finding the cube root. Remember, anytime you've got a negative within the cube root, that means your answer is going to stay negative, because a negative times a negative times a negative is still going to give you a negative. So this one, cube root of negative 8 is negative 2. This one, the cube root of 1,000,000. Notice you have 6 zeros here, and they need to be separated into 3 groups. 1, 2, 3. So cube root of 1,000,000 is 100, because if you multiply 100 times 100 times 100, it does give you 1,000,000. Completing the statement using less than, greater than, or equal to. Number 5, the square root of 17 is less than 4.5, because the square root of 17 is right around, I would maybe say 4.1. If you multiply 4.1 times 4.1, it's going to give you 16.81. So maybe even like 4.2, and that's giving you 17.64. So it's still 4.1, 4.2 is still less than 4.5. This one over here, we've got the square root of 25 1/44, so that's 5/12. Notice how 5/12 is really, really close to 1/2. And if you change that to a decimal, it'll give you like 0.42 maybe. 1/4, that might not be right, so just go back and double check if needed. 1/4 is 0.25, so notice again, this decimal is larger, so we're going to use the less than symbol here, stating that the square root of 25 1/44 is actually the biggest one. Number 7, to the nearest integer. Remember, an integer is a positive or negative whole number, so it didn't actually ask you to change it to a decimal here. The negative square root of 33, I would estimate is closest to negative 6, because 6, that square root is 36, and this one's only 3 steps away from that. So your answer for number 7 should be negative 6. Number 8, your square root that's closest to 190 is going to be 14, because if you know from your square root chart, 14 times 14 is 196, and that's pretty close to 190, so we're going to stick with 14 here. Evaluating the expression, remember anytime you see square roots, you have to evaluate those first. The square root of 9 is 3, bringing everything else down. And remember, order of operations, it does apply here. You're thinking of square roots as parentheses, so if you want to put those two together, you can. 2 times 3 will be next, because that's multiplication on my list. That's going to give me 6. And then 10 minus 6 gives me 4. Bada bing, bada boom. Number 10, you just have to find the square root of 0.25. It might be harder to find the square root of 0.25, so maybe what I would suggest is taking off that 0 in the decimal and just thinking about what's the square root of 25. I know the square root of 25 is 5, but once I come back and erase that mark, I know that I have to have 2 decimal movements, so I'm going to create 1 decimal movement as my answer, 0.5. If you go and check 0.5 times 0.5, that's going to be 25 with 2 decimal movements, and that's what we got up here originally. So the square root of 0.25 is 0.5, and then we're just going to add that to 2.4, which gives us 2.9. 11, you had a word problem. The area of a square game court, remember a square has equivalent sides. How long is one side of the court? Well, if the area is total 64, remember we do length times width to get to your area. And since a square has the same sides, that's essentially taking the square root of 64, which is equal to 8 feet. So 8 feet, answer for number 11. Writing the decimal as a fraction or a mixed number. Remember, this one is the one where you have to do those 4 steps, okay? This one might take a little bit longer to explain. First step is write the original equation. X is equal to 2.37 repeating. The next step is to multiply each side by however many times the decimal is repeating. This decimal is repeating twice. I'm going to multiply it by 10 to the second power, which is equal to 100. So on the left side, I will have 100x. On the right side, I will have 237 with still the 37 repeating at the end. So that was step 2. Step 3 is subtracting the original equation from the problem. Minus x on the left side, minus 2.37 on the right. Left side, I get 99x. Gosh, I gotta rewrite that 7. Sorry guys. 99x on the left side. 237.37. I'm going to subtract those. These 37s on the end cancel out. So all I'm going to have left is basically 237 minus 2, which is 235. And then I'm essentially just trying to figure out how many times, solving for x, no, step 4, can 99 go into 235? I already know it's going to be 2 times because that's going to be my mixed number. So I just got to figure out what is 99 times 2. And that's going to be 198. So what I would do here is just take 235 minus 198, and I would get 37. So my answer is going to be 99 can go into 235 twice, with 37 remaining. I cannot simplify 37 and 99, so this is my final answer. 2 and 37/99. Maybe notice your hint right here. 12 through 16, this is going to conclude the part 1 video. You're just writing it as, is this a rational number? You're just trying to categorize it as with many numbers, as many words as necessary. Number 13 is just rational. I'm just going to write the letters here. Number 14 is irrational because pi is already included in it. 15 is rational because now we know that we can include rational repeating numbers in the rational business because we can also write repeating numbers as fractions. 16 is going to be a little bit of everything. It's a natural number because we can use it to count. It's a whole number, it's an integer, and it is rational. This concludes our part 1 video, so make sure that you go back and you have all the correct answers for 1 through 16. I'm going to go ahead and ask you to stop this video now, and when you're ready, you're going to go find Chapter 14 Review Part 2, and that's going to go over the back page of your review sheet. Thanks for tuning in.